Good morning, everyone. I'm Calvin Manuel Frias from STEM12A, and today we're going to solve some physics problems from Chapter 26, Direct Current Problems 26.11, 26.13, and 26.17. So, first of all, these are all of the formulas that we're going to use for today. And also, we're going to also use the V is equal to IR formula. So first problem, in figure 26.11, R1 is equals to 6 omega, R2 is equal to 6 omega, and R3 is equal to 7 omega. The battery has negligible internal resistance. The current I2 through R2 is 4A. What are the currents I1, I3? And what is the EMF of the battery? So first of all, we're gonna list all of the given values as you can see at the right side. And at the bottom left, you can see the diagram that visualizes our the problem. So since the since the first two resistors are connected in parallel, they're equal. The volts are equal, and then we just substitute it by the V equals to IR formula, and then you, you just substitute the given values, and then you're gonna get the I1s will equal to 4 amperes, and then for the current for passing through 1 and 2, you just add the two amp the two currents, since the currents are connected in parallel, so you're gonna get 8 amperes. And since I1 2 is equal to I3, because they're both connected in series, the I3 is also equal to 8 amperes. So find the EMF of the battery. So since we so first of all, we're gonna use the formula V equals to IR for in order to find the third voltage for V3. So you just substitute the given values, and you're gonna get 56 volts. And V for the voltage passing through 1 and 2, uh since they're connected, it is connected in parallel with V1. you just I you're just gonna get there, since they're both equal to each other, you just substitute the values, and 6 times, which is 6 times 4, and it will equal to 24. So V12 is equal to V1, and they're both equal to 24 volts. So you just add the two voltages that you get from V3 and V12, so you're gonna get 80 volts for the EMF of the battery, or the electromotive force of the battery. Next problem. Compute the equivalent resistance of the network and find the current in each resistor. The battery has negligible internal resistance. So first of all, we're gonna find the equivalent resistance. So the equivalent resistance is just the total resistance of the entire circuit. So first of all, you're gonna get the product over sum of the resistor, which is connected in parallel. So you just substitute the given values, and you're gonna get 2. And for the other resistor, which is connected in also in parallel, you just do the same thing, the same principle. And since the two, when after you get the resistance of the two resistors, they since they are connected to each other, you just add them up, and then you're gonna get 5 omega. So next problem, find the current in each resistor. So first of all, we're gonna get the total current in the circuit. Since we already found that RT is equal to 5 omega, and VT is equal to 60 volts, since it was given in the problem. You just substitute it, and then you're gonna get 12 amperes as the total current. And after you do that, you get the voltage passing through 3 and 6, and you just use the V is equal to IR. Then you're gonna get get 24 volts. And since V the to for the to in our the total voltage passing through 3 and 6 is also equal to the individual voltage. They're all equal to each other, so they're all equal to 24 volts. And after that, you get the current passing through 3. So you use the V equals to IR formula again, and then you're gonna get 24 over 3 is equal to 8 amperes. Same also goes for I6, for the current passing through 6. And you also do the same thing for the next ones, which is this for this one, the same principle. Then you're gonna get the current for passing through 4 or across 4 is 9 amperes, and the current passing through 12 is 3 amperes. Last problem. In a circuit shown in figure 26.17, the voltage across the 2 omega resistor is 12 volts. What are the electromotive force of the battery and the current through the 6 omega resistor? So first of all, you're gonna find the electromotive force of the battery. So you're gonna get the resistance, the total resistance in 1 and 2. So since they're connected in series, you just add them up and then you're gonna get 3 omega. And for the total resistance, you you just use the V equals to IR formula, and then you just substitute the given values, and then you're gonna get 18 over 9 is equal to 2 omega. After that, uh, since you you just is the what you got kanina in our previous step, in order to get the total current, which is 18 over 2, you're gonna get 9 amperes. And then after you get the 9 amperes, you get the since the total amperes is just equal to the sum of the individual current, you just substitute the given values, and then after that you just use algebra in order to find the value of the current passing across 3, which is equal to 3 amperes. Thank you for watching, and God bless you.